Hello and welcome to another tutorial. We are continuing our discussion on the classes, declaring classes, and we said that in general class declarations can include these components, modifiers such as public, private, and a number of others that you will encounter later. However, know that the private modifier for a class declaration can only be applied to nested classes when the declaration of a class is inside the scope of other class, right? And these are called access modifiers, the class name, and that defines the name of your class in the source code, right? And whenever I say that the type, the name of the type, it means the fully qualified name of the class, because we said that if there's a package declaration in your source code, then the name of your type in the actual bytecode, it's not exactly the name that you declare in your class declaration, right? It's the fully qualified name, package dot the name of the class, right? So there's a distinction between the name of the type and the name that you use in the class declaration in your source code, right? And that comes from the package declarations. And we said that in general, the type of the variables, you have to identify them with a type. And again, the type means the fully qualified name. And we said that they added the import keyword and the import statements to make life easier for the developers, right? So the class name with the initial letter capitalized by convention, and we said that this is where did we write it? This is the Pascal naming convention, and we said that for methods we use Camel case naming convention. Other programming languages like Python or C++, they typically use a snake case, right? Either for variables, for methods, for classes. But in Java, we make a distinction between the name of the types. We use Pascal, so the first letter is always capitalized. That's the convention. Obviously, the Java compiler doesn't enforce this. This is not part of the Java language specification. This is just part of the convention or the best practices. And as a good developer, you have to always follow best practices, right? And then Camel case for variables and methods, right? And it's always recommended not to use underscore. And if you're familiar with Java native interface, and if you've watched my lectures on Java native interface, you know that when you try to declare a native method and create a header file for a C++ header file for that native method, this underscore becomes significant, right? So there's a distinction between underscore or not. I'm not going to go into the details, but if you are more interested, you can look at my lectures on JNI, Java Native Interface, to understand why it's better to not use underscore anywhere in your naming in Java source code, because especially if you're dealing with native methods, it's best to avoid this underscoring. The name of the class is parent, superclass, and we generalize this to the concept of super type, which means a superclass or super interface, if any, preceded by the keyword extends. So every class in Java can only extend one superclass, right? Multiple inheritance is not allowed, but we add capabilities to our class by implementing interfaces, because interfaces just abstract constructs. So there is no ambiguity. If two interfaces have the same methods, it's not a problem, just because both of them are abstract. So eventually your class is forced to provide a unique implementation for those methods, right? So that's another thing that led Java to not allowing multiple inheritance, because interfaces are purely abstract constructs. So having same methods signature, i.e. the name of the method, then signature of the parameters, and the return type, it doesn't matter if two different interfaces have the same method, because as long as those are abstract, right? A class can only extend one parent, and if you don't explicitly use any extend keyword, if you don't explicitly mention that what is the superclass of your current class, right, then by default you are implementing the you're extending the object class, which comes part of the JDK. So object class, so the default superclass of any type is Java underscore lang underscore object. And note that this is the actual type, right? So again, get used to the notation of the fully qualified name for your types, because that's actually what's written in the bytecode after the compilation, right? So whenever I say object, it means Java lang object. Be very careful about this. Again, I repeat this many times because most tutorials don't talk about this concept, but that's the main concept. So if I want to declare a variable x1 of type object, what you are actually forced to do is to write x1, the type is Java lang object. But then the import statement allows you to remove this, and you write import Java lang object, right? But then the other thing is that because all the objects, all the classes in the Java lang are automatically imported, which is, so this is implicit. So you don't need to really type java.lang.star. You don't need to write this basically this statement, right? Because JVM, when you launch your application, this will be automatically added, or basically this is implicit. So every type, so a star means this is a wildcard. This is called a wildcard for import, right? This means that any type that has a fully qualified name starts with java.lang. Just import them, right? Then you don't have to write the fully qualified name for all those types, right? So this notation, import Java lang star, means import all the types, the names of all the types that start with java.lang. Obviously this has to be a valid package on the class path, right? Yeah, so you don't need to specify Java lang object because this is automatically imported. Same with other types in your Java lang. We will look at this later when we go more into the details of the classes that are available as part of the JDK. Alright, a comma separated list of interfaces. So we said that a class can, by the way, so if you want to double check that which super type is actually which type this class extends, which we know that we're not explicitly extending any class, so this has to extend the super class. So if I right click, go to source, and override implement method. We looked at this briefly previously, and we said that in Eclipse, when you go here, it also when you try to override or implement methods, so Eclipse creates a list of all the super types, which means all the super classes, or basically one super class, and all the interfaces. And it gives you a nice visual way of selecting which method to override from the super types, right? Because the idea of overriding a method from a super class or implementing a method from a super interface, that's the meaning of overriding or implementing. And you see for this class, which we didn't have an explicit extends keyword, it shows me that the super type is actually object, which is a C class, and it's green, which means it's a public class, so everybody can access it. It has a native method called clone. It's a protected because it's a yellow diamond. It has a public method because it's green called equals. It takes an object as a parameter. It has a method called finalize. It's a protected method, and it has a slash on it, which means it's deprecated. It will be removed. It has a public native method called hashcode, and it has a public method called toString. So you are allowed to basically override any of these methods. And we saw that object has other methods that are final. So if I say open a type object from JDK 16, and we saw that there are some also final methods, and you are not allowed, a subtype is not allowed to override the final method in a super type. Obviously this wait, these methods wait and notify are for multi-threading, so these are really associated with the internals of the JVM, so obviously you shouldn't be allowed to change the behavior. Get class is also associated with the internals of the JVM at runtime, so that means you are not allowed to change the behavior, right? So you cannot override final methods, but you are allowed to override any public or protected. And a subtype never has access to the private parts of the superclass. So private really means private. No other class, not even a child class or subtype, is allowed to access them. A class body surrounded by braces or a pair of curly brackets, and this is called the scope of the class, right? So when you define your class, you create a scope. Everything in Java has to be inside the scope of a class. There is no global scope. There is no concept like that. So declaring member variables, and we said that in Java, we don't say really member variables. We say that fields, a field or a member variable can be static or non-static, but they're allowed to exist inside the scope of a class. You cannot have a variable that is defined outside the scope of a class. I cannot say here in this source code. Remember, I'm in a source code. I cannot say int x1. It's not allowed because there is no global scope. So this is not allowed. Not allowed because there is no global scope in Java. Obviously in Python, in C, C++, you can declare a variable in the global scope because, or basically you can declare a freestanding variable because there is a global scope, but in Java there is no global scope. Everything has to belong to the scope of a class because class or interface or enum, etc., right? Everything has to belong to the scope of a type. Let's say it this way, because a type is a general concept than a class, right? A type means interface, enum, class, etc. So there are several kinds of variables. Member variables, and we said that this terminology is mainly used in C++, but or maybe also in Python. In Java, we say these are called fields, right? Variables in a method or block of code, these are called local variables, and we said that the best practice is to declare them as final, unless otherwise you need to change the values after assignment. So by default, declare all the local variables as final, because that could lead to some compile time optimization. Some calculations the compiler can do them at compile time. And we said that for other cases like switch, the argument of a switch, or the case labels, right, in a switch statement, they have to be compile time constants. So you either use literals or strings, which are final, or you use expressions that only include final variables. Could be a field, a final field, or a local variable which is final. So fields, local variables, variables in method declaration, and these are called parameters. So the official name is parameter. When you actually call that method and pass a particular value for those parameters, those values are called arguments. So there is a subtle difference between saying the parameters of a method or the arguments of a method call, right? So when you define the contract of your method, i.e. the return type, the name, the access modifiers, and the type of parameters that it takes, we call them parameters. But when you call that method with a particular set of values that are passed to the method, those values are called arguments. The bicycle class uses the following lines of the code to define its fields, and these are non-static fields, and these are public, these are primitive types, right? Java allows primitive types for the fields. And fields basically hold the data, which means, and the data means the state of your object. So each object or each instance of this particular type bicycle gets its own state, gets its own data. The reason is that these fields or these member variables are not static. Non-static fields have their own unique copy in the Java heap, right? In the Java memory, and they vary from one instance of the class to another. Static fields are uniquely shared between all objects of the same type. So if some object changes one static field, the other objects immediately see those changes because there are not multiple copies. Field declarations are composed of three components: 0 or more modifiers, such as public, private. If you're familiar with C++, you know that usually in C++ you don't declare every variable, so you don't declare access modifiers for each variable. So in C++, I'm going to go here. In C++, you type this kind of syntax. You say public, colon, and then you declare your variables, int, cadence, for example, int, gear, etc. And this colon creates a scope for this public, and all the variables under this scope are public. But Java decided that this causes some confusion when you read the source code. So they mandated that in Java, so I'm going to write it down. In C++, you have to do this. You have to explicitly you write a public once, and then you put any variables under that, which means all these variables are public, right? But in Java, they mandated that every variable, every method, everything gets its own access modifier. Now this makes code more readable, because if I read the line of code that defines the type of this variable, I can also immediately see what's its access modifier. Is it a public, private, protected, whatever, right? So Java mandated that every variable, every field, every method gets its own access modifier. Obviously, local variables don't have any access modifiers, because you're not allowed to access them outside of method. Or basically, if this parameter is a local variable to this method, which is a constructor, as soon as I hit the end of the scope of this method, then these local variables are destroyed, because whenever a method is called, a stack frame is assigned, And a stack frame is a temporary frame, is a temporary memory area, right? It holds the values of these parameters, and as soon as we hit the end of the scope, that stack frame, that memory area is destroyed, right? So these local variables no longer are available and we cannot access them. Now in C++, there is a concept of static local variables, which means you can actually basically you can actually hold on to the static to local variables and between multiple method calls. But Java decided not to allow that because that could cause to a lot of confusions and bugs, right? So you cannot have a static or a static basically local variable in Java. Same, local variables don't get any access modifiers, right? It doesn't make sense. So I'm going to write it here. So only fields or member variables are assigned access modifiers. And it just means that if somebody creates an instance of this object, can they directly access this? And the best practice is always declare all the fields as private, and then use setters and getters. Setters are called mutators, getters are called accessors. You access them via the get. And this contract allows you that when you have an object, you immediately call .get, and the autocomplete of your ID shows you which attributes of this class you are actually allowed to access. So that's a very nice way to quickly understand which attributes are open to you. You can read them, right? So just directly accessing a field of a class, it means you wanted to read the value. When a variable is public, you can directly say create an object of type bicycle and say that object dot cadence. You directly read this, and whenever you have direct access to a primitive type, obviously you can assign it a value and you're directly changing it. And we saw that when we look at the OOP, and for example in the let's see, was it in the car class? We said that typically we don't want people to directly change the values. Instead, we want to provide setters, because in almost all cases you want to do some checks, because every variable that models a real life object, right, a real life class, there are some limitations on the amount of or the variables that define the state, right? For example, a car, the gear, only in reality it's only car 1, 2, 3, 4, maybe 5 and -1 for reverse, right? So you want to see that, or maybe up to 6. So if somebody tries to assign a value greater than 6, then you have to either reject that assignment or throw some exception, or just print something to the console that, hey, this is not correct. But if somebody directly accesses this, if you define this gear as a public variable and somebody directly says that car.gear 10, for example, then this is very bad. So you can never enforce any checking or conditioning on this type of assignment, because this is a primitive type. This is the assignment operator, so there is nothing that you can do. But with the setters, you can put a lot of logic behind inside the set gear, and then do a lot of checks before actually allowing the change in the state of the object. So setters are always the best practice. All right, so 0 or more modifiers such as public, private. The fields type, it could be a primitive type, it could be a fully qualified name of a class if you have, or an interface, right? Any fully qualified name of a type. And then if you have already used the import statement for the fully qualified name, then you can drop the package part of the name of the type, right? The field's name. So we see that when we talked about the variables and the general rules that you have to follow when declaring variables in Java, we saw what is the type, what is the name, what are the naming conventions. For example, the name of the variable cannot start with a numeric literal. For example, 1, you cannot say 1 cadence or 2 gear or something like that. It cannot, the first letter cannot be a number, cannot be 0 to 9 or dash sign or negative or something, right? It has to start with a letter. The fields of bicycle are named cadence, gear, and speed, and are all of data type integer, primitive type. The public keyword identifies these fields as public members, so people can directly access these fields by using the dot operator. So you create an instance of this class and say that instance dot cadence, and you can say assign something to it. Accessible by any object that can access the class. And public means it's open to everybody in the same package or other package or other project or everything, right? Public is really means you open it up to everyone, and that's generally not the best practice. So the best practice is to make them private, or at least package level access. So you restrict the access to the fields, or the direct access to the fields, only to the other types in the same package. And that was the idea of packaging, right? Package means you group a set of types that are closely related, but you want to keep them separate, right? So I hope you enjoyed this lecture. We will continue this discussion in the next lecture. Please stay tuned, and I'll see you in the next one.